Okay guys, hopefully I've taken care of the microphone issues and we've got a good working mic today. We're looking at 9-4 negative exponents. Yesterday we focused on multiplication and division of monomials that gave us exponents. So we might have come up with a problem like this. X to the fourth over x. And when we divided that, we subtracted the exponents, again with the understood 1 there. This giving me x to the third power. Now today, let's go the other direction. What if I have x to the first power and x to the fourth power on the bottom? If I do the same subtraction, that's going to give me x to the negative third power, because 1 minus 4 is negative 3. So let's write this out. If this is x over x times x times x times x, okay, so that's x over x to the fourth. Using the tools that we know, we can cancel one of the x's on top with one of the x's on the bottom, and that x goes in there one time, so that really leaves me 1 over x to the third. So my question is here, how do I make this one look like that one? And here's how you do it. You're going to take x to the negative third, and you're going to make it into a fraction. So to make anything into a fraction, I just put it over 1. And then you're going to flip it, or take the reciprocal. And when you flip the x to the negative 3 to the bottom, it becomes positive. So take the value, place it over 1, and then take the reciprocal. So let's look at a couple of examples. Let's do 4 to the negative 2, and then let's do 3 to the negative 4. Okay, so 4 to the negative 2, first thing I want you to do is make it, well, a legible fraction. 4 to the negative 2 all over 1. And then I'm going to take the reciprocal of that, which now makes the negative 2 into a positive 2. And I can simplify this because I know that 4 squared is 16. It's computer lab day, so getting a little noise outside. No worries. Let's do the same thing with the 3 to the negative 4. Let's make it a fraction. We're going to flip it and make it positive. And then we're going to actually... Give me a line there. There we go. We're going to actually solve it. So 3 to the fourth is going to be 3 times 3 times 3 times 3. This is a very popular one that we use a lot. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So this is how we write them using positive exponents. Now, let's deconstruct them. Let's work backwards. What if I had let's see. What if I had what if I had 1 over x squared? And I asked you to write this using negative exponents. I'm asking you to write this using negative exponents. At some point, my 2 that is now positive needs to become negative. Well, we found in the other situation that if it was negative on top, when we flipped it, it became positive. Same thing, if it's positive on bottom, we flip it, and it is negative. And this is just simply x to the negative 2 power. What about something like this? How would I write that as a negative exponent? Well, I'm going to want to flip it. And so after I flip it, I don't have any exponents here. Okay, I need to ask myself, how can I make an exponent here? What times itself equals 36? Okay, so what times what equals 36? Now, that's going to be 6 to the second power. But if I want to make it a negative exponent, so I can flip it to the bottom, that's going to be 6 to the negative 2 power. Go ahead and get my boxes around these. Let's do another one of those. If I did 1 over 49, then I would flip it to the top. Now, to make the exponent, what times what equals 49? That's going to be 7 squared. And because I need it to be a negative exponent, it's 7 to the negative 2 power. Let's deconstruct this thing. If I had 7 to the negative 2 power, and I flipped it, these two things should be exactly the same. So that's negative exponents, guys. We will see you in the morning.